Okay, so the next indeterminate form that we want to look at is infinity minus infinity. Now remember, this was an indeterminate form because sizes of infinity can be different. That first infinity could be like infinitely times larger than the infinity that we're subtracting, but it could also be exactly the same size. So these could end up canceling each other out and giving us 0. They could also differ by just like 2 or 3. So because infinities have different sizes, we have no idea what value this takes. Maybe it's infinity, maybe it's 0, maybe it's 84. So it's an indeterminate form because it's hiding some number. Unfortunately, this one is a little bit more challenging than the other known forms because it's really on a case-by-case basis as to what we're going to be doing. So there are 3 main things that we do to deal with this indeterminate form. So how do we deal with this indeterminate form? And the first main thing that we might see is we could potentially factor something out. So factor something out. So you don't have to have a greatest common factor, although that's going to be the best thing to factor out if you do have one. So factor something out, ideally a GCF. But if that's not possible, just something that will get rid of one of those infinities. So it's like we're factoring the infinity to the outside. GCF or something that will get rid of an infinity. Now, the second thing that we might want to do is combine the infinities. And this could be using a common denominator, or it could be using log rules, which if you don't remember, that's okay. We're going to remind ourselves of them in a minute when we do the problem. Using log rules, or maybe we also have to use trig identities. So we will see all of these identities. We'll see all of these. The third one, which I'm probably not going to do an example of because it's the same as what you learned last semester and it's somewhat rare. The third thing that you could do is rationalize. And so this would be like what you did last semester when you had something like x plus the square, or rather x minus the square root of x minus 4 and over whatever, and you had to multiply by x plus the square root of x minus 4 over x plus the square root of x minus 4. So rationalizing shows up somewhat rarely, but is useful in the case where applying L'Hopital's rule just kind of sends you in circles. Useful when applying HR doesn't get you anywhere. Okay, so with this in mind, let's start off with the most basic example of this. So I might have something like the limit as x approaches infinity of x e to the 1 over x minus x. And now when I plug in here, I'm going to end up with infinity times e to the 1 over infinity minus infinity. So this e to the 1 over infinity that we got here, remember that division by infinity is like 0. It's getting really, really small. So this is like e to the 0. So this is 1. And so this does give me infinity minus infinity. Now this is really, really important, and we'll make a note of this in a second. Infinity plus infinity is not an indeterminate form. If both of those infinities are positive, then when you add another infinity, you're just making it bigger and bigger. So the signs here for infinity minus infinity are super important. And I will make a note of that after we finish this problem. Okay, so here I have infinity minus infinity. So I'm going to start by factoring out the greatest common factor. And my GCF here is just x. So we are going to factor out that x to get e to the 1 over x minus 1. And now when I plug in that x is infinity, well, we just saw that e to the 1 over infinity, that really looks like a 0 there, my bad. That e to the 1 over infinity gives me e to the 1 over 0, which gives me 1, so this is 1 minus 1. And this gives me infinity times 0. So that was our other indeterminate form. We're still not allowed to apply L'Hopital's rule. L'Hopital's rule only happens for infinity over infinity and 0 over 0. So what do? We bring 1 to the denominator. So the question is, do I want to do this? Or do I want to do this? Remember, our goal being to bring the function to the bottom that will make L'Hopital's rule the simplest. And here we can see that that's clearly going to be this one. This 1 over x right here is clearly going to be a much simpler derivative than what happened over there with 1 over e to the 1 over x minus 1. Okay, so I'm going to move it to the denominator, limit as x approaches infinity, e to the 1 over x minus 1 over 1 over x. When I plug in, I get 0 over 0. That 1 over infinity on the bottom, that's going to 0. So now I am allowed to use L'Hopital's rule. I'm going to go down here to do it. So here we're going to continue, continuation. And we're going to be applying L'Hopital's rule here to get the limit, as x approaches infinity, we need to not forget our chain rule here. This is going to be the derivative of e to the 1 over x, that's e to the 1 over x, times 1 over x prime. And then divided by the derivative of 1 over x. So at this point, we've done the derivative of 1 over x a few times. We've seen that it's like x to the negative 1. We're just doing x to the negative 1 to get that negative 1 over x squared. But just to make sure that we remember this, here we're doing e to the 1 over x times 1 over x prime, and that's just our chain rule. And the chain rule for e to the g, remember, is saying e to the g times g prime. Notice what happens here. So if I were to plug in right now, I would definitely get 0 over 0. That's a bad plan. What should I do first? If you're saying simplify, you would be right. Remember, we should never immediately apply L'Hopital's rule without first simplifying. And when I simplify here, I can cancel out those negative 1 over x squared to get x goes to, limit as x goes to infinity of just e to the 1 over x, which we've already done. And I get that my final answer here is just 1. So there we go. Final answer. So a note. Just the thing that we were talking about in the beginning. With infinity over infinity, 0 over 0, the signs of my infinity did not matter. Infinity times 0, I mean. So when those other infinities, the signs did not matter. With infinity minus infinity, the signs of infinity are super important. Infinity minus infinity is an indeterminate form. Infinity plus infinity is just infinity and is not an indeterminate form. So before we move on to the next video, I'm actually going to do one more question in this video. I want us to look at a problem that's really similar to the one before. We're still going to use factoring, and we're still going to be thinking about how that infinity minus infinity is important. So our next example here, instead of x e to the 1 over x minus x, I'm just going to look at the limit as x approaches infinity of x minus e to the x. So we're still just dealing with factoring. When I plug in here, I do indeed get infinity minus infinity. A reminder if you need it, the graph of e to the x looks like that. So as I'm going to infinity, my x values are getting big, 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 and that is also going to infinity. So I get this infinity minus infinity. The signs work out for this to be an indeterminate form. So I need to do one of the three things we talked about: factor something out, combine infinities, blah, blah, blah. Well, here I don't have a greatest common factor. So I'm going to factor something out, just something that will get rid of infinity. My two options here, my options are that I can factor out x, or I can factor out e to the x. And it literally does not matter which one you choose. Either way, you're going to get the same answer. It is your choice. Either one works. And it's not like one is better than the other. It's honestly, in this particular case, going to end up with the exact same level of difficulty. So I'm going to go with the x just because that's first. So the limit as x approaches infinity, I'm going to factor out that x, and then I'm going to get 1 minus e to the x over x. Okay, so if I had factored out the e to the x, I would have had x over e to the x minus 1. And either way is a totally valid way to approach this problem. Okay, let's plug in. So here I get infinity times 1 minus infinity over infinity. So at this point, the indeterminate form here is actually showing up as only part of the problem. It's only that e to the x over x. So maybe this is going to end up with infinity times 0. I don't know yet, because I don't know what value that e to the x over x is hiding, right? It's an indeterminate form. It's hiding something. So what I'm going to do is I'm going to call it puppy dog. And we're going to go off to the side and do it and figure out what value it gives. Do I even have an indeterminate form with the whole thing? So in other words, here I'm looking at just the limit as x approaches infinity of e to the x over x. And that's my infinity over infinity. So my L'Hopital's rule isn't showing up in the whole thing. It's showing up as part of the thing. So we're going to apply that L'Hopital's rule to get the limit as x approaches infinity of e to the x over 1. And that is just going to infinity, or rather infinity over 1, which is infinity. So when I look at this thing, when I'm plugging into this thing, this is actually infinity times 1 minus infinity. Well, the answer here then is infinity times minus infinity, which is just negative infinity. So my final answer here is actually negative infinity. Now, just to make sure that you follow, we're going to call this thing a star. 1 minus infinity is the same thing as negative infinity. Because if I am so incredibly, infinitely small, infinitely negative infinity, and I just add 1 to it, do you think that's going to change anything? Is it going to magically take me away from infinity or bring me to a positive number? It's not. If I'm at negative infinity and I just add 1, that 1 is so minusculely small compared to that negative infinity that it does nothing. So 1 minus infinity is just the same as negative infinity. This gives me negative infinity. That's my final answer. I would have gotten the same thing had I done the factoring out of e to the x instead of x. All right, that's all. Next video to see the trig stuff and some other stuff happen with infinity minus infinity.